Moving on to the next portion of acids and bases, we need to look at neutralization reactions. Acids and bases neutralize each other in a neutralization reaction. The general reaction looks like an acid reacting with a base forms salt and water. The acid and the base each give off a hydrogen ion or a hydroxide ion respectively, and the hydrogen ion and the hydroxide ion combine to form H2O, which makes sense from looking at it. There are two hydrogens and one oxygen between the hydrogen ion and the hydroxide ion. They form water. In the end, this is a neutralization reaction because water is neutral. It has a pH of 7. We also end up with a salt formed by whatever is left over from the acid and the base that are not the hydrogen ion and the hydroxide ion. So let's take a look at an example of that. Here's our reaction again, but let's look at a specific example. Here is hydrochloric acid. It's got the H highlighted in this sense because it is the acid. It's going to give off the hydrogen ion. And here's the base, sodium hydroxide. The OH in this case is highlighted because this is the base giving off the hydroxide ion. In the end, this really is a double replacement reaction. What we're going to see here is that the sodium and the chlorine react with each other to form sodium chloride, and the hydrogen ion and the hydroxide ion react to form the water. Let's look at another reaction here. We have sulfuric acid reacting with sodium hydroxide. Again, I've highlighted here where the hydrogen ions and the hydroxide ions are coming from. So again, it's really a double replacement reaction. We of course are going to form water from the hydrogen and the hydroxide, and that leaves the sodium and the sulfate ion to react, forming sodium sulfate, and then of course the water. And then the reaction here is balanced. So what I'd suggest is that you try this practice question on your own. The salt, lithium fluoride, is produced from a neutralization reaction according to the following equation. So for this equation, determine the acid and the base, and then describe how you knew that it was a neutralization reaction. I'd suggest you pause the video at this point and take a moment to complete this question. Okay, so let's check the answer together. Determine the acid and the base. Well, in the end, the acid is the item that is donating the hydrogen ion, and in this case, it is the hydrofluoric acid. The base in this case is the lithium hydroxide because it donates the hydroxide ion. How did we know that it was a neutralization reaction? It's a neutralization reaction because it produces the salt, lithium fluoride, as well as water as products. Let's look at a slightly different style of question that we might come across. This question says, determine the acid and base that produce the following salts. Write a balanced equation for the neutralization reaction. In these cases, we're being given the salt, and we need to figure out the rest of the equation and then balance it. At first it could seem a little tricky, but what we're seeing is, again, the salt, so one of the products, and the other product of a neutralization reaction is always going to be water. Okay, so let's start with the potassium iodide. In this case, again, the logic is that this is the salt that is formed as one of the products, and because it's a neutralization reaction, we also know that water is formed. So let's write that down. Now we need to figure out the acid and the base that react in order to form these products. So we know that the acid is going to be the hydrogen donor and the base is going to be the hydroxide donor. We know that the salt, the potassium iodide, is formed from the acid and the base and the combination of those two ions. So really at this point what we need to figure out is which ion from the potassium iodide goes and reacts with the hydrogen, and which portion comes from or will react with the hydroxide. If we look at the salt, potassium iodide, it's an ionic compound, and so the potassium forms a positive charge ion, and the iodine forms a negative charge ion. And so we know that the iodine with its negative charge will react with the positively charged hydrogen ion, and the potassium with its positive charge will react with the hydroxide and its negative ion. In the end, this is not the resulting answer we want to write down, but we actually want to form the compounds properly. And so to write that out, we see that we have hydrogen iodide and potassium hydroxide form potassium iodide and water, and this is our final answer. Let's look through B together as well. The calcium sulfate is formed. The calcium sulfate is formed along with water because, again, it's a neutralization reaction. As we process through this, we know that the reactants will have hydrogen ions and hydroxide ions because it's an acid and a base. And then we can say which portion of the calcium sulfate will go with the hydrogen and which portion will go with the hydroxide. Calcium forms an ion with a 2+ charge, so it will react with the hydroxide, and the sulfate is a 2- charge, will react with the hydrogen. So we place the sulfate ion here and the calcium ion here. Again, we want to write out the reaction properly with the proper chemical formulas. And so we figure out using crossing over that H2SO4, or sulfuric acid, reacts with CaOH2, or calcium hydroxide, forming calcium sulfate and water. And then, of course, we balance the reaction. What I would now suggest is that you take time to practice neutralization reactions and the kind of questions we just looked at on your own using the practice booklet, Practice 3 section.